All right, so the first type of hyperbola we're going to consider is when the hyperbola opens up to the left and right as opposed to up and down. So, in that, and the center is at the origin. In this case, I should probably write that down, the center is, in these, is at 0, 0. The distance from the origin to this point here, this is the vertex, one of the vertices. This distance is A. So this is the point A0. Likewise, that distance is A, so that is the point negative A0. So the vertices are at plus and minus A comma 0. Notice the foci, the focus is further, that distance is bigger than this. C squared is bigger than A. So in this case, the Pythagorean formula is a little different than that of the ellipse. So for a hyperbola, C squared equals A squared plus B squared. The foci, as I just said, one of them is here at C0. The other one is at negative C0, so those are our foci. The equation, these are the asymptotes. And this just opens up and it gets closer and closer to that asymptote, yeah? So these are the equations of the two asymptotes. So now let's find the foci and vertices in the asymptotes, the equations. So we want this equal to 1. So we need to divide everything by 100. 4 goes into 100 25 times. 25 goes into 100 4 times, and that's equal to 1. Now, for this, it doesn't, an ellipse, we were looking at which number's bigger in the denominator. We don't do that with hyperbolas. The only thing you need to figure out is it of the form x squared minus y squared or y squared minus x squared. That's what matters, right? Which variable comes first. The x comes first, that's this type of situation. When the y square comes first, it opens up and down. That's what we'll do in the next video. So now, here we see the number under x squared, that's a square. So a square is 25. B square is 4. So a is 5 and b is 2. C is the square root of a squared plus b squared. I just take the square root of both sides. So C is the square root of 25 plus 4, or the square root of 29. So now we can find our foci. Our foci are plus and minus C comma 0. Here's our C values. So the foci are at plus and minus the square root of 29 comma 0. Where are the vertices? They're at plus and minus A. A is 5. So the vertices are at plus and minus 5 comma 0. What are the equations of our asymptotes? Well, y is equal to plus and minus b over a. B is 2, a is 5. So we get 2 over 5 times x. And that's what we got. If we wanted to graph this, we would graph this. So we would go up 2 over 5, yeah? And you're going to get something like this. For minus, go down 2 over 5, and you're going to get something like this. The vertices, if I go out to 5, and out to negative 5, and basically we're going to get a situation that looks kind of like this. Right, so that's the graph. Now, just so you know what is, so to find what the A and B are, just to, if I did, this is not a very good graph, but this distance here is A. This distance right here, that distance there is our B. So that's where that B, so that's, notice here, B over A. When I go here, go up B over A, yeah? So that distance is B, that distance is A. That's the slope of this line. So that kind of relates how B and A in this equation come into those asymptotes. But that's the result of working this whole problem, including the graph of our original equation.